So today I'll be talking about best practices for building and maintaining FHIR terminology content. And I'll be looking at, I guess, briefly interoperability, context and content. I will give a brief introduction of the scope and purpose of clinical terminologies, talk about information models and terminologies, the value set development process, and we'll have a look at our value set tool Snapper and probably go through a few examples. Interoperability, context and content. So FHIR is an interoperability standard. I think we've been talking about that over the last few weeks, but communication and interoperability is a multifaceted problem. So to ensure that the correct intent of the author of a message is captured and communicated, it's important to understand both the content and the context. And this applies for both computer systems as well as for humans. So context is, or a message is more than just the words, it's the context as well. For example, the word cold or COLD, are we referring to chronic obstructive lung disease? Are we referring to the sensation or temperature of being cold? Or are we talking about the common cold? Without context, it's hard to know what we mean. So clinical terminologies are coded vocabularies, and when they're used within an information model, that will give you the context and the content. And this allows you to accurately name and identify concepts relevant to healthcare, create relationships between these concepts to provide context to meaning, and it allows you to communicate information without loss of detail or change to meaning. So clinical terminologies are structured vocabularies used in clinical practice to accurately describe the care and treatment of patients. So some examples of these are Snomed CT, LOINC is a laboratory one, and HPO is a common genomics one. There will be next week, I think there's a Snomed introductory session if you're interested for more information. So where do you use clinical terminologies? Generally, you would use them at data entry because they give you the content coverage and specificity to allow clinicians to record what they want at the point of care. But clinical terminologies also allow the idea of single provision, so record once, but then it can be used multiple times. So you are then able to use that information that's been recorded for communication, for retrieval and reuse. This is because it's standardized, and there's also terminology features such as attribute relationships that can be leveraged to help you do that retrieval. So information models and terminology. So the terminology binding provides the links between the information model and the terminology. It allows you to constrain the set of possible values which can populate a given coded data element in the information model, or it can be used to define the meaning of an information model artifact using the terminology. Terminology binding is an important part of supporting the following clinical information system functions. So data capture, retrieval and querying, information model library management, and semantic interoperability. So your information model, so for example, FHIR, will define the data entry boxes, so the names of the fields, whereas the terminology model defines the values which can be selected and recorded within those boxes. So they're the values. So it's really important that those name value pairs make sense to clinical users and to computers. So here's an example where when we look at them within your information model, you have a diagnosis field. It's really important that the concept is selected from your correct hierarchy or from the correct context within your clinical terminology. Here you can see there's two different concepts, hematoma, but they kind of look the same, but these are Snomed codes, and in the Snomed world, a morphologic abnormality is sort of at the cellular level, whereas the hematoma disorder is really referring to what the actual diagnosis is. So in this particular example, the first one is actually from the wrong hierarchy, which isn't necessarily a problem for a human, but if you're trying to do retrieval, if the concept is not from where you expect it, it may be difficult for you to get that information back out. It's really important to make sure that concept selected relates appropriately to your subject of record. So if you have an information model and you've got a field for diagnosis and a field for family history, you can put in a concept or a term that says Crohn's disease, and that would mean that the subject of the record has Crohn's disease. If you put the same value, Crohn's disease, into a different field for family history, you're now saying that the family member has Crohn's disease. So even though you're using the same value, the meaning has changed due to the context. So if you have a different information model, perhaps just a generic clinical notes field, to get that same kind of information, I now need to pick two different codes, one for Crohn's disease and one for family history of Crohn's disease. The other thing to be aware with information models and terminologies, sometimes you get semantic redundancy, so where information is repeated between different fields. So for example, in this one with the anatomical location and the laterality field, here we've got left foot as the body site, and we've got an additional field for laterality, which we've filled in as left or blank, which isn't a problem in itself. Or you could split that out to left and foot. And with these ones, there's no problem here, but sometimes it may open up to nonsense coding options. For example, here I've got left nose, and in example 2, I've got right eye, but the left laterality, which doesn't really make any sense. So it's important to think about these things when you're binding values and you're thinking about your information model. So when you are building your value set or binding a value set, you need to think about your information model and the data element it's being bound to. And what is the use case of your value set? What is the scope? What's your intended use? Your binding strength and any downstream impacts, as well as maintenance. And I think I'll be talking about most of these things next. So some principles and tips to building these terminology resources, and they're with everything, design first and then do. Think about the process, and this was similar to the mapping process that I spoke to before. You need to identify your use case, design, develop, then publish and implement, and then there's always maintenance at the end. So first up is identifying your use case. So the method of creating a value set and the selection of its members are tightly bound to the value set's purpose, use case, and requirements. So to do this, you need to define your scope and your requirements. Think about what is the main purpose of this value set, who is the intended audience, what is the scope of content, who is responsible for developing and maintaining the value set, and what information models will this value set be bound to, and what is the binding strength. So an example use case would be for data entry. So value sets can be used to constrain and control search. It can be used to constrain data entry. It can be used to exclude content, or it can be used to reduce noise for users. So some of the considerations you should think of is your binding strength. So that's, I guess, the indication of the degree of conformance expectations associated with a binding. So if you do have a binding strength of required, you probably need to be quite expansive with what you've included in your value set, because you're not allowing use of any other terms other than what you've selected in your value set. But if you're going for preferred or example, you could be a lot more lenient or relaxed with what you include. The other thing you need to think about content. So where you get your content from, you may be using source data. So you may have previous lists of things that you want to include. There may be existing value sets, perhaps national, international, or local standards that you want to turn into a value set. You may build your own specifications built through literature searches, or you may have content SMEs who are experts in the area and they know what content they want in their value set. Another thing that you need to think about is the downstream use and impacts of constrained or short favorite lists. think about where that content goes. So at the point of care might be the first place that the data starts, but it may move into clinical records. It may be used for funding or for clinical registries, biosurveillance projects, or research projects. So often those decisions of what you put in your value set can have impacts further down. And then maintenance. I think this is with any kind of artifact that you do need to think about maintenance. The next use case example I've got is for recall, retrieval, and analytics. So value sets can also be used to define criteria for recall of health records, perhaps for reporting, for funding, for analytics, for research, or to validate data. And these ones, unlike perhaps data entry ones, these would be maximal to catch all because you don't know what might have been used. Some things to think about is what are the actual data entry value sets and their implementations and what those implementations allow. Are there different versions of terminology in use in source systems? So if you're collecting data from multiple source systems, there may be different versions of the terminology. And again, maintenance. And just with mapping, so concept maps can be used as well to define a map from a set of concepts defined in a code system to one or more concepts defined in other code systems. You could use mapping for migration or backward compatibility, mapping for continuous use, to validate data for proxies, as well as for aggregation, categorizing, and reporting. And I gave a presentation about this one last week. But again, just briefly, the considerations are maps are really tightly bound by their use case. And so it's not really reused. So you do need to take a lot of thought about whether reusing a map is appropriate for your situation, and what rules were either your map that you're building or the map that you're trying to reuse. What is the scope, the version, the map direction, and the map relationship types. So if you are designing a value set, you need to think about what type of value set are you required. What kind of content development approach should be taken to develop your value set? So are you basing it on existing specifications, whether it's your own or national, international type specifications? Or are you using perhaps existing data? So are you starting from a top-down approach where you're trying to catch everything? Or are you going bottom up and looking at very specifics in your frequency and then adding them all in? You need to think about what tools you have available to create the value set. That may impact how you build your value set. If you are using something like Snomed, which has hierarchies, which hierarchy will the concept belong to? And also then what is your maintenance plan for your value set? In terms of development methods, you could, depending on your scope and requirements, you could create a new value set from scratch. You could adopt or copy an existing value set, which is already available. You may want to adapt an existing value set, and by adding extra members or removing or excluding members. It's really important to make sure that the value set meets your requirements and that the content selected is sufficient for the context where the value set is to be used. And it's really important to test and validate it to make sure that it meets your needs. When you are building new value sets, we generally recommend there's generally two approaches. One is the manual enumeration, and this is where you are selecting individual members to belong to this value set. So you're picking them one by one. This does give you greater control of the membership of the value set, but it does give you a greater maintenance burden because you do need to check each one every time you update versions of your terminology. The other way of building a value set is intentional, or using queries or rules to define value set members based on their qualities. And these can be dynamically updated. So in some ways it is less maintenance burden, but if they are large value sets, you kind of do have less control because things are being added by the rules and not by individual selection. With all your value sets, it's really important to document the rules of value sets, so to allow for maintenance and future reuse. You can do this through a logical content definition, so the compose component in the FHIR spec. And then for people, there's a narrative description for humans to read. This is the value set spec here. With maintenance, it's important to remember to consider any changes to your user or system requirements, changes to source and target code systems of your concept maps, and think about your use case. If you're doing retrospective value sets or concept maps, you probably don't need to do maintenance as they're a snapshot of a point in time or single use, but some use cases do require maintenance of retired content. For intentional value sets, because they're rule-based, they'll generally update every time you run the query, but with extensional value sets, you do need to manually update them. With the maintenance, again, some terminologies have some mechanisms to help with the maintenance. They may provide version control, full history tracking, deprecated statuses or retired statuses, and some like Snomed provide a historical association reference set. So that will provide you a link to any concept that has replaced or updated an old one. And you can use those files to help with the maintenance process. Okay, I just wanted to quickly show this here is our snapper tool, and you can use it to build any FHIR resources. So with this tool, you can build code systems, you can build value sets, and you can build concept maps. So it has a tour function here, so you can use it to walk you through building any of these things. But I thought I might just show people quickly some of its functions so you can see. So this snapper tool currently is pointing to our public Ontoserver here, but that can be changed if you have your own terminology server, FHIR terminology server, you can point it to that so you can use that. You can find any existing resources on it by clicking this button here, and this is a list of all the FHIR resources. These are all the value sets, but you can look at concept maps and code systems that have been updated, and they can be found here. So this tool here allows you to build your own code system value sets and concept maps. And so to build a code system, I would just click here. I would give it a title. I do need to give it a URL, and this is part of the FHIR spec, and it's used to identify a code system. And I can give it a description. Once I have that, I have this field here, and I can add codes down here, and I can give it other bits of information. So I can import codes from a file. So I've got a file here. I tell it what it is, and I note which one is the code column, and perhaps I've got some descriptions. I've got a header row, and then I can import my code. So I'm able to import my code system here, ready to upload. Snapper also, if it is a simple code system, you can build your properties. So you can give things properties, and you can add them to each of these things here. You wouldn't do this for really complex code systems. I think there's better ways to do it. But if you wanted to just do simple ones, this builder could do it. Once you've finished that, you can add additional metadata. You can put a narrative, and you can put things like your publisher name, your date, what status it is, all of these bits and pieces. You can add some narrative to it, and then when you're ready, you're able to actually upload it to the FHIR server. It also provides some validation just to make sure it meets the whatever FHIR specification, and you can actually download it as well. as a JSON file. So once you're done, you just upload it to the file. And so that has been created. So my sample code system 1 here. If I want to create a value set, I can do that as well. So I just create a new value set here. I have to give it a name and a URL as well. And once I've done that, I'm able to now add things in and exclude things. So I can include codes or exclude codes explicitly. So I can pick one code by one code, but I can also include filters as well. So if your code system has filters defined, then you're able to use those here. So I might show some of that a little bit later where we use some Snomed codes and Snomed filters. You can also use build concept maps here. It's not the easiest to do, and I'll show you how to use that in a little bit. So I've just got some examples coming up that I might use. So when you are thinking about value sets for data entry, it's important to think about what you are using that value set for. If you are using a value set for perhaps a form, think about how the form might display those things and whether it's worth building a value set. So here, the members of the value set could be displayed as radio buttons. There could be tick boxes, and you could also bind a search type field to a value set as well. So this one here is probably a much longer value set. The clinical manifestation value set, I think, has maybe close to 1,000. So you wouldn't use a tick box, you would use a search kind of field. So I've spoken about setup. Okay, so I thought I might give a few examples of how you might want to build a value set for data entry. So this is an example perhaps for reason for medication discontinuation. And this particular one might be for a form, and I might have a drop-down tick box kind of thing. So I just want to briefly touch on Snomed's expression constraint language because I want to build my value set using Snomed codes. And I think we'll have a bit more information next week about Snomed, but I just wanted to briefly touch on this. This is the query language native to Snomed, and it matches concepts based on its descendants, ancestors, relationships and groupings, number of relationships, and it does relationship navigation, and it does have its own syntax. So this here is Snomed's hierarchy. And so ECL will let you move up and down the hierarchy. So for example, here from bone finding, you can find things to the right of it, which is more specific, or it will let you traverse upwards the hierarchy to its parent and ancestors. So you can move left, which is less specific. Snomed also has a concept model where information is modeled, definitional knowledge is modeled into its structure. So you can see here fracture of upper limb. It has an associated morphology of fracture and a finding site of bone structure of upper limb. ECL will also allow us to create queries that will allow us to find things as using those attributes or definitional information. So I can find this expression here is asking me to find all types of diseases with an associated morphology of fracture and a finding site of the bone structure of the upper limb. So that would identify this concept here. It allows you to identify descendants and self, has relationships. So you can, these relationship pairs here, you can query those, and then as well as relationship groups. This is the shrimp browser, and I will show you that in a moment. And it does have, and it's freely available and it's online and you can find it here. Within the Shrimp browser, there is a button that will take you to this page, which is a sort of a high level shortcut table. So if you want to have a look at that, you can, and it gives examples of some basic queries that you can use with it. So back to my example, if I want to build a value set for data entry, so for reason for medication discontinued, I want to think about what are the possible values. So I've given myself a hint. There is a Snomed concept called medicine discontinued. So I will just have a look at that now. Oh. So here I've got medicine discontinued, and I can see it in the hierarchy that it has a lot of descendants that are really useful, and I think perhaps are candidates for my value set. So drug treatment stopped at medical advice, clinical trial stopped, the drug therapy was discontinued because of duplicate, it was ineffective, but there are some things in here that I don't particularly want in my value set, some very specific things. So what I will do is create an ECL query, which will query Snomed and use this as a starting point. So if I go to the ECL builder, I can create a new one, and I can create, so it was medications discontinued. And I want all the descendants, so anything that's sat to the right of this concept. And I can find here that there is 20 different ones here. And I just want to make sure that it was anything that was related to a drug therapy. So now I'm down to 17, and I can see here, it looks pretty good. This thing only will show you the first 100, but because mine has only got 17, I can look at it quite freely. And I can see this one here, the warfarin and the thyroxine probably aren't what I want. I can use this thing, this part here. I can exclude specific concepts. So the concept was warfarin stopped. I can also exclude thyroxine stopped. And I want any, and it was phenoxy, injectable phenothiazine stopped. So I have a look at this now. I'm pretty happy with this. I can see the one thing that's not here, because it has been stopped. Perhaps I want to put patient non-compliant. So I will try and find another one, and it will, I need to redo this, but I might choose to add it, and I have to add it a different way. Might want to add that in. So I now have 15 things in here from 14, and so all of these should be in here, I hope. So once I've got my my query, so this is my query here, I'm able to take this and put it into my value set. So I can copy the ECL from here, and I can go back into Snapper. So I want to create my value set. So I've got this example value set that we just created, but I don't have anything in it. And I want to create an include filter. I can select my code system. So I'm using Snomed. And just needs a minute, I think. Sometimes, okay, I'll select Snomed. I can put in the property of constraint equals, and I can paste in that ECL query. So that's bringing that query from the ECL builder into here. And I just removed the blank one just to make sure it doesn't. I can include extra codes, I can exclude codes, or I could create another filter and exclude that. So we can see here we've got additional metadata fields and narrative, but I can now check here, it's got the value. So this here is the preview of the FHIR resource. And I can download the value set so I can see what it looks like. So this is it here, and it's expanded it out. So from that query, I now have the specific Snomed codes that are included in this value set. So once you've done that, you're then able to upload your value set, and then you can use it in whatever implementation that you want to. Another way of creating a value set might be by mapping. So here are some common signs and symptoms that you might want to include in a form, but you want to convert them to a terminology like Snomed. So I've got this list and I can use Snapper to help me do the map, and then I can use it to create a value set as well. So I've already created, for me to be able to create a concept map in FHIR, your source code system has to be your source codes have to be made into a code system first. So I've already done that. So I've created my concept map, and I've specified my source code system, my source value set. So those are my source codes. And then I've now noted that my target code system is Snomed because that's what I'm going to map it to. I can then import my codes. So I'm doing hepatitis symptoms, CSV, and I know my first column is my source code, and my second column is and that's it. I then import it, and it can see I've got these sort of labels here. This tool does also have an auto map function. So I just select everything and hit auto map, and it will find the best match it can from Snomed. Oh, sorry. But before I do that, sorry, I've forgotten to put a value set. So I know these are all clinical findings. So I'll do that. And then I'll run my auto map. So the auto map is looking for best matches within the clinical finding reference set. So any descendants of the clinical finding hierarchy that match these codes. So you can see here, it's done an okay job. It's found jaundice, fever, fatigue, nausea and vomiting. It's matched to vomiting without nausea. I don't think that's what I mean. I can replace it. So I can look for values in my thing. So I've got nausea and vomiting, and I can drag and drop that down. Oops, sorry, I think I dragged and dropped it incorrectly. So I just replace my jaundice back. And then once I'm happy with that, so you can go through them one by one and make sure that you've mapped them correctly. And then when you're done, you can upload it to your FHIR server if you want to use it as a map. If you want to turn it into a value set, you would import your codes. Sorry, you would export your codes. So I think we go to upload to FHIR server, we download the concept map. Actually, I think we have to, sorry about this. You would actually create your map in Snapper Map, which is the tool that does exactly the same thing, but it would give you back a CSV file. So when you create a map here, you're able to do the same thing. and then you are able to actually download it as a tab separated file. And then you can take that tab separated file, take it back to Snapper Author, and then upload that as a value set by doing exactly the same thing. The last thing I wanted to touch on was thinking about your value set for your use case. So for example, if you have a type of liver cirrhosis field that you want to field, there's different types of answer values that you could use for your value set. If you're building a data entry form, depending on your use case for your form, you might only want to include 2 things. So you may only want to include decompensated cirrhosis and perhaps compensated cirrhosis. But if you are building an information model, you may want to be a lot more expansive with what you select for that. So Snomed has a concept for liver cirrhosis. Just let it load. So Snomed has a concept for liver cirrhosis. Sorry, my internet might be a little bit slow here. So it is taking a little while. So it has cirrhosis of liver. And when it loads, you can see it has a whole bunch of different types of cirrhosis of liver or subtypes, which you might wish to include. And you can include those by creating an ECL query, like I showed you, the same as previous. So I might want to find all descendants or self of cirrhosis of liver. And Snomed has 63. So depending on what your use case of your value set, you might want to include all of these, or you might want to pick, cherry pick 1 or 2 that you expect to see on your form. So I guess, yeah, what I'm just saying is that the use case for your value set is really important. So just in summary, as I was just saying, use case again is king. It determines your content, but please do think of the impact of sharing those value sets and maps. Think about your binding strength and interaction within your information model. How does that name and value pair match together? And then think about your development approach. You do generally want to try and keep your maintenance as low as possible. So yeah, thank you. I hope that has been useful.
Thank you very much, Ms. Kylynn. Now, Ms. Kylynn will answer some questions. You may type the question in the chat box, or you can open your microphone to ask the question after using the raise hand button.
Hi.
Yes.
Hi. Thank you very much. I have one question. It seems like you are demonstrating like the when we developing the software, we talking about the lookup table or some kind of the data dictionary, which is has some value map. So how about create a code system like maybe the hospital provider registry, and if we have some kind of the information model, how it relationship, like the health center is also part of the district office, and also part of the hospital clinic or something like that. Is it possible for us to create a kind of the code system or the terminology system like those in Snapper Over.
Yeah, if you want to, you can build code systems so you can make your own code systems, so local code systems for use within your hospital or within, your ministry or whatever, using Snapper. It's pretty good for building simple code systems which don't have a lot of relationships. But if you are building, I know you're interested in the TMT, and that you could probably build some of it within Snapper, but it's quite complex. You might lose some information. I think Jim's online. Perhaps you could elaborate a little more.
Yeah, there's a couple of reasons there that some of the relationships are too complex, and it's too big. Snapper is only really useful for code systems up to about 20,000 codes, and then after that it's too big. And you have to write a program in Java or Python, JavaScript or something that will produce your fire code system. So, but for something like locations in a health service or identifiers of practitioners is an interesting one. If it's changing regularly, then if you want to express it as a code system, you run into issues of maintenance, of having to, update the code system really often and have lots of different versions, which might be complicated. You can do it, but whether a code system's the best way to do it or whether just doing something like a naming system, which doesn't include all the content, but just gives you some way of identifying the system that the codes come from, would be another possibility.
Could you share us about how Australian develop the core system of the healthcare providers? Do you develop by the Snapper, or they have some kind of the one group that do programming to developing those? Over.
So there is HL7 Australia has a provider directory project. They don't use the code system resource for that. I believe they might have a naming system resource just to say what the official URI is for those identifiers, but there's nowhere that there's a single list that's published as a FHIR resource of all of those identifiers. There's just too many and it changes too quickly. So they don't encode that as a FHIR code system, the practitioner identifiers. You can do it on a small scale, but it's complicated from a maintenance point of view because that list probably changes every day. And having to release a new version of that code system every day and then make sure that people are up to date is too difficult. So instead of doing that, they have a central place where you can connect in and get a list of all the practitioner resources or the location resources or things like that. But they don't use code system for their provider directory.
So what you mean is that you may the Ontoserver maybe request that source of that sort of the provider identifier to get the value set into the system. Is that what you mean?
No, basically we don't use a terminology server for provider directories in Australia. Okay. There are separate products that do that. So. I think that there may be, I believe that Queensland might be interested in using the terminology server so they have facility codes, which will tell you which hospital or which clinic someone might be referred to. They may be looking at a terminology service for supporting that, because I know those locations have codes and they change a lot less frequently. So that's a similar sort of problem.
Right now in our country, we are trying to do kind of the create a registry of the provider. So that one of the things that we are going to create it in the near future in Thailand, both for facility identifier like the location and characteristic of the health of that facilities, and also the individual. And it seemed to me that you think the Ontoserver may be not appropriate to maintain to maintain and host or provide this kind of the registry to the I mean the application,
Yeah.
or the file. Yeah.
It's certainly not the direction that has been taken in Australia. I'm just going to post a link into the chat right now. So this is the project in Australia that they've been working on for provider directory. So this has a FHIR implementation guide for describing how it works based on R4. I haven't followed it very closely, but it's really more about using the practitioner resources, organization resources, location resources, healthcare service resources. So I haven't been involved in that closely, but I know it's been a piece of work that they've been doing for a number of years now, and I think it's in use. Kylynn, do you know if provider directory is in use yet? Or
I'm not sure. I haven't been following it closely either, unfortunately.
Yeah, but certainly that implementation guide at the link that I just sent through would be definitely interesting to look at if you're looking at building a provider directory.
Okay, thank you. Any comment or suggestion for the SEAL team or from Lemon? How Philippines doing that? How Philippines do using the Ontoserver, and what are you going to do to use that? Oh, that's a silent. That okay. And Kylynn, it's very interesting, and I think we learn a lot from that. And what for me, what I learned most is that it's quite complex in terms of what we think that the Ontoserver can be more can serve us several things, but it seems like we have to do more. Ontoserver definitely very benefit, but to serve like if another registry, then we have to learn. I mean, to study more in another. I mean. The scope of what we have to work on is quite very expensive now, but it is good. It's good, and I really like the a lot of function that the ECL that you that Ontoserver could provide that.
Yeah,
Thank
there's a
you.
lot of things. No problem. There's a lot of moving parts. I think Ontoserver is just one tool, but there's so many things, so many parts, and information modeling and terminology working together to make forms, to make information models. It's quite complex. So you really need to think about when you're collecting data, why are you collecting data, and what information do you want to collect, and what do you want to do with that information later, and make sure that you collect the right things at the right time so that when you go to reuse it later, everything is there. Everything's in your value set already. So,
yeah, I mean, I think really the technical parts of using a terminology server are a little bit complicated, but they're not too bad. But the really important things are that there's these questions you ask yourself about the content before you start. And if you answer those questions well, then you use the technology and everything is much easier. Whereas if you don't ask those questions at the start, like establish your context of use and things like that, then you can start using the tech and find yourself in trouble later. So it's just some process stuff, but if you do it well, it makes things fairly easy. But if you don't, it can make things very hard.
Let's see. Maybe I'm not quite sure that this question is quite related to this. Can Ontoserver help in doing the post coordination, create a value set for the post coordination term from the Snomed city?
It will support post coordination, so you can create, if you know the syntax, you are able to create post coordinated expressions, say with Snomed. But before you do that, you need to again ask yourself questions like, why do I need it? How will I use it? If I use it, and I send it to someone else, will they be able to use it? Will they be able to unpack it and understand what you meant? All those things. Or is that content actually a gap in the content, and someone should actually fill the content and make the content more full? So before you do post coordination, I would ask myself those questions. And if post coordination is still the way, then yes, Ontoserver can support and help to kind of carry that syntax. Jim, did you have anything you wanted to add?
I think that's a good way to put it. It would be very easy for us to say, yes, Ontoserver is the only product that can let you do post coordination, but you do need to be careful about using post coordination for the reasons that Kylynn says, that if you're sending your codes to someone else, are they going to be able to understand those codes if you're and are they going to be able to use them in a meaningful way? So it's worth considering, like, why you need the post coordination, and are there other ways that you could do it? For example, using an information model that Kylynn talked about early in her presentation. I mean, if you're just combining, I don't know, condition codes with lateralities, then is it an alternative approach to have a separate field for laterality in your information model, or for severity or things like that? So, and sometimes it makes sense to separate them in the information model. Sometimes it does make sense to put them in as post-coordinated expressions, or sometimes it makes sense to go back to the person who's publishing Snomed and say, can I have this new concept, please? And they can add it. So yeah, it's worth thinking strategically about the use of post-coordinated expressions. And then if you do, as Kylynn says, if you do decide they're the right choice, then Ontoserver supports using them, testing the subsumption between post-coordinated expressions, including them in value sets, building up libraries of post-coordinated expressions in value sets. You can do these things with Ontoserver.
Thank you, Ms. Kylynn and Sir Jim and Dr. Bunchai. Is there any other questions from the other participants? I think there is a question in the chat box. Should we use concept map to mapping between TMT concepts, such as the generic product use with trade product use?
I might have a go at this one, Kylynn, but please correct me if I get it wrong. But I think when I was reading the documentation about the TMT, the link between TPU and GPU is a parent-child relationship. So that's the way, when we did our sample code system, that's the way we modeled it. So if that's what you've done in the code system, if you've used hierarchy to to model that relationship between GPU and TPU, then you don't need a concept map to do it because it's already in the code system. On the other hand, there are some relationships. In AMT, for example, the relationship between the trade product, now I'm going to get this wrong, the trade product and the trade product unit of use, I think is not hierarchy. It's a relationship, and that one's actually encoded as a property on the code system. Is that right, Kylynn?
Yeah, I think that's right. It has a TP.
As a TPU rather than its use.
Yeah, so you build it into the code system itself rather than mapping them outside of that, because you want to be able to use those relationships much more quickly and easily. I mean, you could map them, but that wouldn't be the ideal solution for when you're trying to actually use them, you know, in your actual implementations.
It's really it's a little bit a style question, because you can do it as a concept map, or you can do it as relationships that are in the code system itself, whether those are hierarchy relationships or property definitions in the code system. And it just depends. It depends on a number of things. If the map between the concepts and the code system are always in sync, then it might make sense to put it in the code system. Whereas if the map evolves like on a different time scale to the code system, then you might prefer to use a concept map resource for it. If they're hierarchical relationships, I would say you definitely want to put them in the code system as hierarchy.
Thank you, Miss Kylynn and Sir Jim. Is there any other questions? If there is no more questions, so this concludes the webinar. Thank you again, Miss Kylynn and Sir Jim, for answering the questions. And thank you, participants, for joining us tonight. Please also join the Ontoserver training next Wednesday. Thank you, everyone.
Okay. Jim and Kylynn, thank you very much. It really, we are really appreciate that. We learn a lot from that. Thank you. Bye.
Bye.
Thank you, Dr. Loi. Thank you, others.
Thank you.